Find f prime of x for the given function using log differentiation. For the first step, let's replace f of x with y and write the cube root using the irrational exponent of 1/3. The given function is equivalent to y equals the quantity x cubed plus 5x divided by the quantity x to the 6th plus 3 raised to the 1/3 power. And now to apply log differentiation, we take the natural log of both sides of the equation. And now we expand the right side as much as possible. Because we have a quotient, we can use the quotient property of logarithms, where the log of m divided by n is equal to log m minus log n, which means you can write the right side as natural log of x to the 3rd plus 5x minus natural log of the quantity x to the 6th plus 3 raised to the 1/3 power. And now we can apply the power property of logarithms to the second log here. We can move the exponent of 1/3 to the position of the coefficient, which gives us natural log y equals natural log of the quantity x to the 3rd plus 5x minus 1/3 times the natural log of the quantity x to the 6th plus 3. The next step is to differentiate both sides of the equation with respect to x. The derivative of natural log y with respect to x is going to require the chain rule. We first differentiate with respect to y, which gives us 1 over y, then we multiply it by a factor of dy dx. This is implicit differentiation, equals on the right, differentiating with respect to x, the derivative of natural log of the quantity x to the 3rd plus 5x is equal to 1 over u times u prime, or 1 over the quantity x to the 3rd plus 5x times the derivative of x to the 3rd plus 5x, which is 3x squared plus 5. Then we have minus 1/3 times the derivative of natural log x to the 6th plus 3 with respect to x, which again is 1 over u times u prime, or 1 over x to the 6th plus 3 times 6x to the 5th. Let's go ahead and simplify on the right. For the first product, nothing simplifies. We have the quantity 3x squared plus 5 over the quantity x to the 3rd plus 5x minus. For the second product, we have a common factor of 3 between 6 and 3. 3 simplifies to 1, 6 simplifies to 2, which gives us minus 2x to the 5th all over x to the 6th plus 3. And now we need to solve for dy dx by multiplying both sides of the equation by y. On the left, y times 1 over y simplifies to 1. 1 times dy dx is dy dx. We have dy dx equals y times the difference of the rational expressions. So while this is the derivative, we prefer to express the derivative with respect to x only in terms of x. So now we replace y with the original function. Let's do this on the next slide. So now we do have dy dx only in terms of x, so we could leave it in this form. But let's go ahead and distribute this first fraction and then simplify as much as possible. And I'm going to go ahead and put all the numerators and denominators in parentheses to make the simplifying more clear. Looking at this first product, notice how x cubed plus 5x divided by itself simplifies to 1, giving us dy dx is equal to, for this first product we have 3x squared plus 5 all over the quantity x to the 6th plus 3 to the 1/3 power. Now looking at the second product, nothing simplifies, but when multiplying the denominators, because the bases are the same, we add the exponents. 1/3 plus 1 is 4/3, so the denominator is going to be the quantity x to the 6th plus 3 to the 4/3 power. In the numerator, we distribute 2x to the 5th, which gives us 2x to the 8th, and then plus 10x to the 6th. So while you may be able to leave the derivative in this form here, it may also be expressed in this final form here. I hope you found this helpful.